Today's topic is software estimation, and it is a very important step in the software development lifecycle. Over the years, I have learned and used some of these methods and would like to share them with you. If you have any question about the content, please do share in the comment section and I'll try to get back to you. Let's quickly run through the agenda for this lecture. We will learn what an estimate is, why we need it, and what the estimation process is. We will learn some high-level estimation techniques and some formal estimation methodologies. WBS is the most popular technique, and we will look at that with few examples. For those from the Agile world, we'll learn about the reference story for estimation. And finally, we will also touch upon the Wideband Delphi and the function point estimation methodologies as well. Let's get started. So what is an estimate? An estimate is forecast of the work, cost, and time of a project with given scope. An estimate is associated with some level of uncertainty and is almost never accurate. Irrespective of the methodology that you use to come up with an estimate, there is always some amount of variance associated with it. We will look at how we can address that down the line, but let's look at how we can improve. Is there a magic wand? I would say no. You have to learn from your past experience. You have to share learnings across projects. And as the team matures over a period of time, so does the estimates. So the next question is, why do I need estimates? Estimates are one of the project deliverables. It drives the financial and non-financial aspects of the project. Whether you're procuring funds, hardware, software, human resources, you'd have to come up with an estimate for it. Estimate is also an input to the schedule of the project. Now that we know the importance of estimates, let's look at the estimation process. As you can see in the diagram, you have multiple inputs. We have the business requirement document, user stories, design document, and meeting minutes. Some organizations maintain the historic data of estimation and come up with the productivity norms. Examples of productivity norms are: consider the productivity of individual resource is 85%. The average experience of a resource is 5 years. It will take 4 hours to develop a ASP.NET page with 2 fields, so on and so forth. So with these inputs to the process, we can come up with a size, effort, and a schedule for a project. And based on the risks and assumptions, we'll add contingencies. For example, if you don't know all the requirements of the project, or you don't have enough human resources available, or there is a learning curve involved, these get added as contingencies to the estimate. Once we have the size, effort, and schedule defined, then we come up with the estimated cost for the project. It goes through the review process and the cycle repeats. Eventually, we will end up with a defined estimate for size, effort, and cost of the project. Approved estimates is updated in the historic data for future use, and the team moves on to the next phase of the project. So you know by now that we are trying to forecast work, cost, and time of a project with given scope. Let's look at all the factors that impact the accuracy of the estimates. The scope of work, functional and non-functional requirements, experience with estimation, technical expertise, domain expertise, complexity of the architecture, risks and assumptions. So it is evident that the estimation requires experience and expertise. Hence, it is always owned by the subject matter experts, the team leads, or the application managers. Let's look at a rough order of magnitude estimate, or RAM estimate. A RAM estimate is a high-level estimate and takes place very early in project's life cycle, mainly during the project selection and approval period and prior to project initiation in most cases. The main purpose of RAM estimate is to provide the decision makers with the information necessary to make a decision on whether it makes sense to move forward with the project based on the estimated level of effort in terms of completion time and cost. Developing a RAM estimate is a skill, and it has to be performed by subject matter experts who understands the nitty-gritties of estimation and has some prior estimation experience. And secondly, when developing a RAM, it is important to understand that the estimate is a rough order of magnitude estimate with accuracy of plus or minus 50%. Depending on the source, the variance can be as much as 100%. A variance of minus 25% to plus 75% is also common for ROM estimates. Let's look at ballpark estimates. Ballpark estimates are similar to ROM estimates in many ways, only difference being less uncertainty, more knowledge about the project, fewer dependencies. Ballpark estimates too takes place very early in a project's life cycle, during the project selection and approval period and prior to the project initiation. Ballpark estimates provide decision makers with the information necessary to make a decision on whether it makes sense to move forward with the project based on the estimated level of effort. Here too, estimate is provided by SME who is knowledgeable and experienced. Accuracies is slightly higher in comparison to ROM at 65% with a variance of plus or minus 35%. Now let's look at the budget estimates. If you were to set up a workspace in cloud or evaluating the off-the-shelf product for your organization, budget estimates comes handy. Budget estimates is a high-level estimation technique. Use it when there's no ambiguity, most of the requirements are known about the project, there are fewer dependencies, risks, or assumptions. Budget estimates too takes place very early in a project's life cycle, during the project selection and approval period. Just like other estimates, budget estimates provide decision makers with the information necessary to make a decision. And like the other two techniques we have already discussed, budget estimates is provided by SME who is knowledgeable and experienced. Accuracy is at 90% with a variance of plus or minus 10%. Here's a quick summary of the three high-level estimation techniques. As mentioned before, they can be used at different cost estimation levels. ROM can be used when there's high uncertainty and little to no information is known about the project. If you estimate the project at $500,000, be ready for the total cost of the project to go up to $1 million. Ballpark estimate can be used when there's less uncertainty and better understanding of your risks, assumptions, and dependencies. If you estimate the cost of the project at $500,000, your project cost can vary between $200,000 to $800,000. Budget estimates can be used when you have very good understanding of the project requirements with little to no ambiguity. The estimate stays intact for the most part of the project, but having a contingency of let's say 10% is always beneficial. Now let's look at the work breakdown structure estimation technique, which is the most popular estimation methodology, and it is one of the formal methodologies to estimate for any given project. What WBS does is it uses a hierarchical structure to organize tasks by splitting them into subtasks. Each descending level of WBS represents an increased level of detail. There are two types of WBS: activity breakdown and functionality breakdown. We look at both with examples. Estimation is done at each leaf node and aggregated based on 100% rule. What is 100% rule? Throughout the hierarchy, the sum of the work at the child level must equal to 100% of the work represented by the parent. What WBS does is it increases the probability that every requirement will be accounted for without duplication. It follows divide and rule policy for managing the scope, and it ensures that the work that makes up the project has been defined. Again, this way of estimation requires breaking down the work, and estimating involves experience and expertise. Let's look at WBS with a few examples. The first example is that of a data consolidation project. Notice the activities highlighted in yellow and sub-activities in orange. Breaking the tasks to subtasks requires experience and expertise. When you do so, estimation becomes that much easier. Let's look at another example, a product such as a human resource management system. Notice how the product is broken into functions, modules, submodules, and activities. The 4 levels of hierarchy makes estimation easier and ensures that all the requirements are considered at the time of estimation. Let's look at another example. Let's say we are enhancing an existing application. Notice how the different phases of the project has been divided into tasks and subtasks. WBS makes it easier to cover all the requirements of the project and gives confidence to the execution of it. Here is a sample WBS template. Now this can vary from one organization to other. Alright, next let's look at the reference story estimation. For better understanding, let's restate some of the buzzwords used in the Agile framework. What is a user story? A user story is general explanation of a feature written from the perspective of the user or customer. What is a story point? In simple terms, it is a number that tells the team about the difficulty level of the story. Difficulty can be related to complexity, risks, and efforts involved. Story point estimation is typically performed at the product backlog grooming session, and the product backlog is evaluated by the team who is responsible for the actual development. The frequency of these grooming sessions can vary depending on the backlog. What is sprint planning? Sprint planning is an event in Scrum that kicks off the sprint. The purpose of sprint planning is to define what can be delivered in the sprint. Now let's get to a reference story. What is a reference story? A reference story is a user story that is not necessarily the easiest, but the story that everyone within the team agree with. So in this case, as you can see in the diagram, I have represented a user story with a story point of 5 and 21. So when I'm estimating new stories, all I have to do is pick a story and say, will this take longer than the reference story X, or will it take less than the reference story Y? As simple as that. So if a story requires a story point of more than 21, you would have to look at breaking it down such that it can be completed within a sprint. Most often in the Agile world, estimation is performed in terms of user stories and story points. In case the organization is not fully Agile, there will be a hybrid environment with some functions in the organization following traditional processes, while some functions are Agile. For a project manager to make sense of such situation, there is a hack which can be used for determining the delivery milestones or for determining project matrices. Of course, the velocity of the team will not always be the same, but this is for estimation purposes only. Let's say at full capacity, if a sprint team of 5 can deliver 90 story points, and the maximum capacity for 2 weeks for a team of 5 is 400 hours. We can easily come up with story point to effort mapping, something similar to the table you see on the right. With the resource loading against the user stories, we should be able to deliver or derive at the delivery milestone and plan the capacity based off of the resource availability. The regular KPIs and matrices for the project manager to track can also be easily arrived at. Now let's look at the Wideband Delphi estimation technique. This is an iterative method of arriving at estimation wherein a group of SMEs bring their experience and expertise, discuss among themselves, and arrive at an estimate. When is Wideband Delphi technique useful? When the size of the project is large and involves multiple complexities in terms of technologies, environment, or processes. When there's no single person who has all the knowledge to estimate, that's when Wideband Delphi technique will be useful. It's also useful when the risk of inaccurate estimates are high. So as you can see in the diagram, at least 2 methods of estimation will be used by independent teams. If the difference in the 2 estimates is less than 15%, you accept the estimates. If the difference is more than 15%, then something might be missing in either of the techniques or one of them. So what you do in such a case is you would loop back with the teams, understand why there are differences, and come to a conclusion. If I were to give an example of when I'd use this the technique of estimation, I'd say, let's say if you or your organization is trying to build a supply chain management product where there are multiple modules involved, you'd have to bring all the SMEs and divide them into two different teams, arrive at an estimate, and you'd usually have a moderator who would review each estimates, schedule the meetings to discuss further, and arrive at consensus. I hope that was helpful. and I was able to clarify what this estimation technique was about. If you still have questions, do drop a line in the comment section and I'll try to get back to you. Okay, we have come to the last section of this lecture, which is on function point estimates. A disclaimer here is that my knowledge on this technique is purely academic. If you have to add any details, feel free to let me know in the comment section. Let's begin by defining what a function is. A function is a unit of measure to express business functionality. Much like a user story, a function is a functional user requirement for a complete user transaction. In function point, the function points are calculated by counting screens, files, database table, reports, queries, so on and so forth. And there are certain keywords that you need to be aware of when it comes to function point estimation. External inputs such as screens, external outputs such as reports, external inquiries such as queries, internal logical files such as database, and external interface or logical files such as objects or files which are external to the application in question. There are two other element types that we need to be aware of. One is the data element type and the other is the record element type. Data element type represents a unique non-repetitive field which is used to analyze the 5 components which we just described. And record element type is a data element type in a database or an interface file. Now for these 5 different components that we just described, we need to come up with a with a complexity metric, something similar to what you're seeing on the screen. In terms of RET and DETs, we are going to arrive at a low, average, high complexity metrics and assign up function points to each of those complexities. So using this, we will be able to arrive at an estimation for any application. Now let's look at an example. So as you can see on the screen, I have taken a screen grab of a Google landing page. So how many points do you think are there on this screen? If you guessed it as no function points, that is correct, because it's just a navigational data and it does not have any persistence to it. So there's no function points allocated to this screen. Let's look at the next screen where you are seeing a result for hello world. When you type hello world on the search screen, it gives you a response back with this screen. So in this case, you have an external output, which is the resultant screen. You have a database from where this data is being fetched, and there's a query involved, which is an external inquiry. So based on these 3 components, you are going to refer back to the complexity metrics, arrive at what function points you have to assign depending on whether it's a low complexity or high complexity function, and then you would assign a total function point to it. In the screen, you're seeing a sample worksheet, which is basically giving you the total function points for search results. Similarly, if there are other functions in the application, you would be assigning a function point to it. So overall, with all the function points arrived at in this fashion, you would have a total function point estimation for this specific application. We have come to the end of this lecture. I'm hoping that you have learned a thing or two by watching through the video. Let's quickly summarize on the estimation methods we've learned. We went through the high-level estimation methods, which is mainly used pre-project initiation stage, and then we learned about the formal estimation methods. WBS and reference story is by far the most widely used estimation technique. There might be some overlap with what function point does, but these two are by far the most important techniques to be aware of. I hope it was helpful, and thank you for watching. If you like the content, please do subscribe. Thank you.